Hello everyone. In today's video, we are going to cover Chapter 11, Section 5, Areas of Regular Polygons. After studying this section, you will be able to find the areas of equilateral triangles and find the areas of other regular polygons. The area of an equilateral triangle. Equilateral triangles are encountered so frequently that a special formula for their areas will be useful. So Theorem 106 states the area of an equilateral triangle equals the product of 1/4 the square of a side and the square root of 3. So the area of an equilateral triangle will equal side squared divided by 4 root 3, where s is the length of a side. Now looking at the area of a regular polygon, so recall that in a regular polygon, all interior angles are congruent and all sides are congruent. So in my figure to the right, I have regular polygon PENTA. O is the center, OA is a radius, and OM is an apothem. So a radius of a regular polygon is a segment joining the center to any vertex. Notice that the radius will bisect the angle. An apothem of a regular polygon is a segment joining the center to the midpoint of any side. Notice that an apothem is the perpendicular bisector of a side. Here are some important observations about apothems and radii. So all apothems of a regular polygon are congruent. Only regular polygons have apothems. An apothem is a radius of a circle inscribed in the polygon. An apothem is the perpendicular bisector of a side. A radius of a regular polygon is a radius of a circle circumscribed about the polygon. And a radius of a regular polygon bisects an angle of the polygon. So if all of the radii of a regular polygon are drawn, the polygon is divided into congruent isosceles triangles, where the altitude of all these triangles, if I draw one in, would be my apothem. So if I write an expression for the sum of the areas of these isosceles triangles, I'll get the following formula for a regular polygon. So the area of a regular polygon will equal 1/2 the product of the apothem and the perimeter, where A is the length of the apothem and P is the perimeter. Now I can use these steps to find the apothem and or a side length. So I'll create a right triangle by drawing the apothem and the radius. I'll find the measure of the interior angle of my polygon where the radius intersects the vertex. I can use the interior angle's sum formula, which is S equals n minus 2 times 180. Then divide that by n, then by 2. Then I'll use special right triangles, either 45, 45, 90 or 30, 60, 90, or trig, remember SOHCAHTOA, to find the apothem and or side length. Looking at some examples, I have a regular polygon, has a perimeter of 40 and apothem of 5. Find the polygon's area. So remember, area of a regular polygon is 1/2 the apothem times the perimeter. So the area of this polygon will be 1/2 of 40 times 5. 1/2 of 40 times 5 will be 100 units squared. Looking at problem 2, an equilateral triangle has a side 10 centimeters long. Find the triangle's area. So I know area of an equilateral triangle is equal to side squared divided by 4 root 3. So if I have a side length of 10, 10 squared divided by 4 times root 3 will be equal to the area. 10 squared is 100. 100 divided by 4 is 25 times root 3 is 25 root 3. So the area of a triangle with a side length of 10 centimeters is 25 root 3 centimeters squared. Problem 3. A circle with a radius of 6 is inscribed in an equilateral triangle. Find the area of the triangle. So I have triangle ABC with radius OP. Notice that OP's length is 6 and that AOP is a 30, 60, 90 triangle, which would make OP an apothem. So if my right angle is here, that would make AO my hypotenuse, which would be a length of 12, meaning that AP would be a length of 6 root 3. Since OP is an apothem, that would make my whole side length 12 root 3. So if I have 3 sides in my equilateral triangle, that would make my perimeter 36 root 3. So now I can use my formula for a regular polygon of area equals 1/2 the apothem times the perimeter. So my area would equal 1/2 the apothem of 6 times the perimeter of 36 root 3. So my area would equal 108 root 3 units squared. Number 4, find the area of a regular hexagon with sides 18 units long. So I want to use my formula area equals 1/2 apothem times perimeter. So I need to find my apothem and my perimeter. Well, I know my side length is 18, so my perimeter would be 18 times 6, which would be equal to 108. Now that I have my perimeter of 108, I need to find the length of my apothem. Remember that an apothem is a perpendicular bisector of a side. So it creates a right angle as well as splits my side into 2 equal parts. So if my whole side length is 18, that would mean part of my side length would be 9. Now if I draw in a radius, I create a right triangle. I can find the measure of this angle by dividing the measure of a regular hexagon's one angle by 2. I know a regular hexagon has 6 angles and that a regular hexagon will be 720 degrees. So 720 degrees divided by 6 is 120 degrees. So each angle in a regular hexagon is 120 degrees. Now, if I drew in my radius, that will bisect my angle, meaning that this angle here is 60 degrees. So I have a 30, 60, 90 triangle. So my side opposite my 60-degree angle would be x root 3 and would be 9 root 3. So my apothem length would be 9 root 3. So now I have my apothem and my perimeter. I can plug them back into my formula. So I'd have 1/2 times 9 root 3 times 108, which would give me a total area of 486 root 3 units squared. In this lesson we learned the area of an equilateral triangle equals the product of 1/4 the square of a side and the square root of 3. And the area of a regular polygon equals half the product of the apothem and the perimeter. That's a wrap on this video. We'll see you in the next one.